This deskproto tutorial shows you how to machine a bust of Abraham Lincoln. CNC specialist NC Techniek in the Netherlands has ample experience, as you can see here, and kindly offered us the use of their machine for a video shoot. This can of course be used for any person's bust, a politician, a movie star, sportsman or woman, your CEO, even your grandmother. On the internet you can find many fine geometries. This one was bought at cgtrader.com. So let me start deskproto to create a toolpath for this Abe Lincoln statue. We are at the start screen. I want to use the wizard for this project. Here's the wizard. First check if your machine is correct. This will be the machine that you selected when installing deskproto. And for this statue we need a rotary machining wizard. First thing as always is load the geometry file. It's listed here, abelincoln.stl. You can see here a nice statue. The width of the shoulders is the largest width of this statue. Well, my wood is 144 millimeters wide, so I want to take that as max size for X, as in this orientation X is this width of the shoulders. So here we are, 144. The other X's will be scaled uniformly. Now I need to align the statue with the rotation axis. That's twice 90 degrees will do the job. Here we are, nicely aligned. This one needs to be checked. I can show you what happens if I don't check it. As you can see, here's the rotation axis, here's my geometry. This is not what we want, so I want to have the geometry centered around the rotation axis. That's it for this wizard page. I can continue to the next page, which is about the material block and the supports. My material block is a bit larger than the bounding box of the material that's displayed here. So I'll set it to custom and enter the correct dimensions. Is 250 millimeters for the x-axis, the length of my block. It automatically makes the support blocks a bit longer, and the diameter as well is a bit larger, 150 millimeters. Yeah. Next thing is the support blocks. This one is okay. This one, where the part will be connected to my rotation axis table, needs to be a bit larger, so I'll set it to custom, go to detail settings, and I can either graphically adjust, or in this case I'll do it using the keyboard, and now I can enter 30 and minus 30 in all directions in order to have a nice cylinder support tab of 60 millimeters diameter. Here we are, 60 millimeters diameter. The zero block, here it's on the rotation axis on the left side of the block. That's okay. And my machining depth needs to be half of the diameter, so in this case 75 millimeters is okay. Next, roughing operation. I want to do roughing with a 6 millimeter ball nose cutter, so I can keep it here, the selected cutter in place. Feed rate is okay. Spindle speed is not. For wood I want to use the maximum spindle speed of my machine, 24,000 RPM. The roughing skin needs to be 1 millimeter to be removed during finishing, and my layer thickness needs to be 10 millimeters. Okay, next to the finishing page. Finishing will be done with a smaller cutter, obviously, for more detail, 3 millimeter diameter. Here as well, 24,000 RPM. And next, and I do not yet want to calculate toolpath or save toolpath in a file, because some finishing details need to be set in the operation parameters that are not present in the wizard. So part parameters are okay, nothing needs to be done here. Scaling, rotation, material block, all has been entered in the wizard, so that's all okay. But in the operations we need to make some changes. First, for roughing, the strategy, it says toolpath along the x-axis. I want my toolpath to go round to have a rotating block, and I want them to start on the far side of the geometry to keep as much material connected to the rotary axis table as possible. So I'll select around a-axis reversed. Roughing is okay. The area, I want my area a bit smaller. Here we are, the area to be machined. I'll simply make it a bit smaller on both ends. That's the area to be machined. No changes for the borders. I want to make the free movement height a bit higher, just for a safety precaution. And in the advanced parameters, I have one setting here in the extra start and end commands. At the start of the file, I can add a movement to Y is 0, as normally rotation axis toolpaths do not contain any Y-axis movements. Now this one is added at the start of the file to make sure that the cutter moves to a position exactly above the rotation axis. Okay, these are the roughing settings. Here are the finishing settings. Same change for the strategy, around a-axis reversed. Nothing here. Also this one needs to be smaller even, as I do not want my 3mm cutter to machine the vertical surface that below the statue. So here I am for the finishing operation. No borders, movement, advanced. Here again the Y is 0, command edit. Okay, here also okay. Now I've done all settings that I need, and I can start calculating the toolpath, which will take some time. So I'll feel free to get myself a coffee. And here we are. Very many toolpaths. You can see the finishing, which closely follows the geometry, and the roughing, which goes down in a number of layers of 10mm each. Okay, for the finishing we can zoom in a bit and see many toolpaths are present. Here is an undercut. The cutter cannot reach within the nose of Mr. Lincoln. Here's a second one below the chin. However, these do not matter, as the resulting statue will be great anyway. So here are all toolpaths, and the last thing to do is to save the NC file, which for my machine is a .iso file. It can be .tap or any other extension. It depends on which machine you have selected. Okay, Abe, and you will see that two files are, the first roughing and then the finishing, which of course is much larger. Two files are saved, as this machine does not have an automatic tool changer. So already we can go to the milling machine. Well, after we machined the geometry, we decided that a socle with some text on it would be nice, as our block is large enough. We forgot to add that in when originally creating the toolpath, so we'll just add the socle now. We reopened the project, and what I want to do is make this support block a bit larger to make it a socle, and then project some text on it. So in the part parameters, I go to the support and I use the edit the left tab, as I want to make that larger, not 30 but 60 millimeter, to make it 120 millimeters diameter. So we double the size, that's okay. And for X we'll also add 30 millimeters to the left to double that as well. Here we are. When I apply, you can see the larger support block, which has now become a socle. Well, we also need to make the block of material a bit larger, as deskproto cannot calculate toolpath outside of the block. So for material, it's now from 0 to 250, and here I enter minus 30 as well. Here we are. So now we have a nice socle that we can use to print the text on. Well, to read the text, I have to use this one, which is load a vector file. The text has been prepared in a vector file. Here it is in a certain font, and here we are, Abe Lincoln. That's the text I want to be projected on the base. So the first thing I need to do is rotate it, and that can be done in the part parameters. As you can see now, a new selection has been added. Instead of just the geometry settings, there are also vector settings with different tab files, and here are the transformations for the vector data. So this is the rotation I meant, minus 90 degrees. It will keep warning me. Here we are, just get it here. So it's now nicely wrapped around my cylinder. However, it has to move downward a bit to get it to the socle. That's the next change in the vector settings to X, vertical. This is the X-axis, as you can see, minus 140 millimeters. And here we are, Abe Lincoln. The text has been nicely positioned where we want it. Okay, now in order to create toolpath, we need to add a vector operation. These two are both geometry operations, but for vector data we need to use a vector operation. Here we are, and in a vector operation I can select the machining depth, the cutter, and for the machining depth I want to show you how I have calculated that by having a bottom view. Here we are. This one is the now I have to say, to show, look here, this one is the diameter of the material block, which was 150 millimeters, so the radius is 75. This is the support block, diameter 120, so the Z value is 60. Well, the machining depth of a vector operation is from the top of the block, so this is minus 15, and when I want to machine 1 millimeter deep, I need to enter minus 16 millimeters, which is what we can do right here. Z settings is minus 16 millimeters. Okay, smaller tool. For the text I want to use a 1 millimeter diameter tool. The thick cutter cannot enter into all characters. Z settings, I just did that. And for the text I want to use pocketing. Pocketing means removing all material inside the closed contour. And I want to use all closed contours, So let's see what happens when we calculate toolpath. Oh, not for these operations, only for the vector operation. Calculate toolpath, yes. Here we are. And now I can see that layers are used, roughing layers, which is obviously not needed here as all material has been removed already. However, I can't switch them off as this is the first vector operation of this part. So what I do is use a trick. I copy this vector operation, copy, I call that one text, and this one will be called dummy, as this is an operation that we will not use. I make it invisible, and now as this is the second vector operation, I can switch off using layers, and when I calculate toolpath now, I don't see anything, which makes sense as the toolpaths are 1 millimeter deeper than the geometry. So when I switch off the geometry, double click, switch off the geometry, here I see the toolpath. However, these are not very nice for text. I want to use a different strategy. I should have done that in the first place. Instead of parallel toolpaths, I want to use offset toolpath. And when I now say OK, these are the toolpaths that I want to use for my text, and these are nicely 1 millimeter below the surface, as I can show you this way when I also now show the geometry not rendered but as wireframe. You can see here is the geometry and the toolpaths are nicely 1 millimeter below the geometry. So okay, here we are back to the rendered geometry, and in fact I'm all done now. I can save these toolpaths to an NC file as well. That doesn't matter because we enter the material 1 millimeter anyway. Okay, and I say Abe text, one too many here, and now we go again back to the milling machine.